Welcome back, guys. Now this video, maybe two videos here. Have you ever had a car, and we're specifically talking about a GM car, but this can really apply to any cars out there, and you got your fuel gauge and it will get down to maybe a half a tank, and the next thing you know, the pointer is starting to move over the place here, moving, drifting, and then as you go further down, as the needle goes further down, then it gets wider and swings, and then the next thing you know, all the way over to full. So in this video, we're going to look at the circuit. We're going to see how it works and how we're going to diagnose this to see what the problem is. Now this car is going to be for a 2000 Buick LeSabre, but this can also apply to, say, any GM car from 97 up to 2005. Because all of the values and resistances that I'm going to be talking about, it can cover this span of years. Alright, so let's get started. Alright, we're looking at the circuit here for the fuel level sensor circuit, high voltage. Okay, if you have this here particular problem, you're going to get a DTC of P0463. Basically what it's saying is that the PCM, the computer, has sensed that there is a higher voltage on the sensing circuit for this here level sensor. And what will set this condition is that if the computer sees a voltage of at least if it sees a voltage of more than 3 volts for at least 10 seconds, then this here will set this code. Okay, this code here will not illuminate the check engine light. Okay, but however, if it does come on, it's going to stop the evap circuits from running, and so this is what we're going to be looking at for the circuit. Now you can see here's a PCM that's inside the dash box. We have an ignition voltage that's fed through a pull-up resistor, and here we can see that this is where the computer is looking at the signal, and also you can see the line goes down, goes over here to the fuel sending unit. This is connected as a rheostat. When you see this here, one end is connected to the wiper like this. The other side is going back to the ground, which is located inside the PCM. Alright, now this voltage that's sensed right here by the PCM is also sent to the IPC. That's the instrument panel cluster. That's where your gauge is located. This signal is transmitted over the Class 2 network to the instrument cluster, so it can be used to be seen on the fuel gauge. So let's take a look more at this circuit, and we're going to break it down a little bit so we can see how we're going to diagnose it, and also we'll see how this thing works. Alright, first we have the PCM. We're going to have an ignition voltage that's fed through a pull-up resistor. Now we're not going to worry about connectors and that kind of stuff. We're just looking at how the circuit is working. Okay. Now this will go back inside, and there's our sensor ground. At this point right here, this is where we're looking at the fuel sender signal voltage. Okay? Now, the diagram showed it to be like this. Okay? This is our fuel sending unit right here. Now, for GM cars from 97 to 2005, when the sending unit is all the way to the bottom, it's like a float, that this here is a variable resistance, that when we're empty, it's going to be equal to 40 ohms. When the tank is full, it's going to be like 250 ohms. Okay? Alright, so that means that, let's say this wiper is moving up and down across this here resistance. Okay? So in this position, let's say right now, you can see that from here to here I'll have a resistance from the wiper to this here outside leg, I'll have a resistance. And if I measure from the wiper to here, I'm going to have a resistance. But you can see that this part of the resistance is shorted out. So the only resistance that's really looked at by the PCM as far as the voltage drop is from the wiper to this point right here. So let's say that in this position right now, we're in an empty position. So from here, so we have this resistance from here to here, through here to ground. So we're going to have this fixed resistance of 40 ohms. Okay? Now as the tank is filling up and it goes to being full, the wiper is going to move down on this here resistance. The wiper is going to come down here, putting more resistance in the circuit until we get up to being 250 ohms when it's full. Okay? In an industry, you will see pots and rheostats. What you will see, now you won't see this on automotive prints, I've never seen it, but in industry, you would like to know which way is this wiper going to go to the function that it's going to do, as far as being empty or is it going to be full. So what they would do is you would draw an arrow through the wiper, and then off to the side here you will say full. So that means that the wiper is moving down as it's going full, as your tank is getting full. Okay? Now let's draw this up a little bit easier. Here's our ignition. Here's our pull-up resistor. Here is our fuel sending unit, which is varying. Sometimes if you see an arrow going through a resistance, it just means it's a variable resistance. And also, there's our ground. Now keep in mind that the ignition and the sensor ground is inside the PCM. Okay? So what we have here, and there's the point that the computer PCM looks here. I'm going to say that. Now keep in mind that this is no more than a voltage divider. A voltage divider is two or more resistors in series across a voltage source, which would be in the ignition, which would be say from 12.6 to your charging voltage maybe up to 14.2 volts, and then our ground. Now as you can see that if we're starting off at 40 ohms where the tank is empty, that this is going to be a lower resistance, I'm sure, than this. And I like to actually know what this here resistance is in this tank. Not that it's going to help us in diagnosing the problem, but in the second video here where we actually repair this problem, I'd like to know what that is, just for my reference. So that means that this here is going to have some voltage across here. Now you can see that this voltage that's across this here fuel sending unit is actually the voltage that the PCM is looking at. And as this here resistance increases as it goes to being full up to 250 ohms, then that means that the higher the resistance, then the higher the voltage drop that's going to be across the sending unit. Okay? Alright. Now, let's take a look at how we might want to diagnose this. Let's start off up here. We're going to say empty. Okay. We're going to say 1/4 tank. And we're going to say here, say 3/4 tank. And over here, we'll say full tank. Okay. Now, we know that over here when it's empty, it's going to be 40 ohms. We know over here when it's full, it's going to be 250 ohms. Now we can take a resistor, a fixed resistor, carbon resistor, and we can figure out, we can simulate the action on the fuel tank gauge to be sure that it's actually going to work, okay? Now, if we look at this, a really, really quick way to see if your wires are working, if I was to go in there, and if I was to unplug the connector, that means I'm going to have infinite resistance. That means that my gauge pointer should go all the way to full. Actually, probably will go past full on the fuel gauge, okay? And if I was to come back in here, and if I was to take and short, let me just take this out right here. So basically, we had the fuel sending unit out of the circuit. I unplugged it, right? So that means that this voltage just sitting here is going to rise up to the supply volts, say 12.6. That's what the computer is going to see. That's going to make the gauge go all the way over. Now, if I take and put a jumper wire from here to here, well, now you can see that what's happening is I have just pulled this point to ground, 0 volts. So now 0 volts is going to be at this point. That means that the gauge should go all the way back to 0. I mean, all the way back to empty, maybe even beyond empty. Go back beyond it a little bit. That test, those two tests right there has confirmed that the gauge is working and that the wires are okay from the sending unit all the way back up to the fuel gauge. It also has confirmed that the class 2 network is working inside the instrument panel cluster. So you have checked all of that. What we don't know is, we like to know, is the fuel gauge calibrated? Is it reasonably close to where the resistance of the sending unit, is it matching up to where the fuel gauge needs to be? Okay? And so we will do these two tests right there. And also to check the calibration of the gauge, let me get that right back in there again. Okay. We're going to use this method right here. Now we know empty is 40 ohms. We know when the sending unit is full, 250. Okay. And actually, let me put one more in here. Let me go back. I'll say 1/4 tank here. Okay. And we'll come down here. We'll come down here. And I'm going to put in here 1/2 tank. So let's add him in there. Okay. If I want to know what is the number between 250 and 40, which will give me 1/2 tank, the way I can do that is I take these two numbers, I add them together. I take 250, I take 40, add them together, I get 290. Then I take and divide it by 2. 290, so let's figure that out. So 2 and 9, whoops, sorry. That should be 4. Terry, you can't even do simple division. 2 and 9 is 4. 4 times 2 is 8. And that's going to be 145. Okay, so for 1/2 tank, it should be 145 ohms. Okay. Now let's say that we just for purposes of discussion, let's say I wanted to know what 1/4 tank is. Well, I can look at the extreme of 145 to 40. I can take and add those two together. I get 185. I take 2 divided into 185. And that's going to give me 92.5. So here is going to be 92.5 ohms. Finally, we can also look at this one right here for 3/4 tank. So I can look at this as my high end, this is my low end, add those two together, which is 250 plus 145. I got 395 divided by 2 to find the middle of where those two numbers are at, and I get, whoops, 92 is 18, 115, so I got 197.5. Okay? 197.5 ohms. Now we have all the information that we need to diagnose this. All right. So let's say we go in there, we unhook the sensor, the level sensor. Now let's just say that I'm going to put in, I want to say half a tank. I want to see if this here fuel gauge is going to register a half a tank. So 145 ohm resistor is what I need. But now for a standardized resistor, you will see that 150 ohms is a standard. And that'll be close enough for our purposes of what we want to do. So I'll take a 150 ohm resistor, I'm going to jump it out, and I'm going to put it right in there. Okay? There's our sending unit. Now, we're going to get a certain amount of voltage. It's going to go back up here. PCM is going to read it. And our gauge should go right to being a half a tank on the gauge. All right? Now, if we see that, we know the gauge more than likely is set to be calibrated. But if you want to play with it some more, you know, like let's say if we wanted to see if it'll read a quarter tank. Now here, 92.5 ohms, we don't have a standard value for that. Now you could take resistors and put them in parallel and series, and you know, it can come out to pretty close to this value. But in our case, for what we want to do, if we can get in the ballpark and it reads pretty close to being a quarter tank, then we're good enough. So for this one here, we could use 100 ohm. So here we could use a 100 ohm resistor. And for this one over here, we could say we could use a 150 ohm resistor. Okay? Once we see that the gauge is working correctly, we're done. So we know we need to put a fuel sending unit in there. And I suspect that's pretty much what the problem is going to be here. 9.9 times out of 10, if you see your fuel gauge fluctuating, usually when it gets around a half a tank, it gets a little bit less than that, and it starts really going back and forth. And what's happening here is, and you'll see sometimes it'll go all the way back and shoot over the full. And what you know right then, from what I just told you, is that then there's an open circuit where the wiper is sliding across this resistance. And when it hits that certain spot, say about a half a tank or maybe a little less, then you got an open circuit. And the voltage just shoots right up, and then say for that voltage is going to go beyond the 3 volts, and it's going to be on there for longer than 10 seconds, then that's when you're going to get your P0463, which is a fuel sending unit, high voltage on that circuit. So that's where we're at right now. Okay, I just had a question from my wife, and she was asking me,
what is the wiper?
what is a wiper? What does that mean? Okay, well, let's go. Then we'll have to go back over a little bit more basics onto the pot, potentiometer, and a rheostat. All right. All right. So now we got this information here. So I'm going to erase it. Okay. Okay. On a potentiometer, there's 3 terminals. Okay. And this is typically what you will see. Okay? You're going to have this terminal up here, terminal down here, and a terminal down here. Now let's just say for the purposes of discussion, let's say this is, let's just say it's our 250 ohm pot. Okay? 250 ohms of resistance.
Okay.
If we take our ohm meter and if we put it across the outside legs meaning this one and this one, not the one which is the arrow. The arrow is the the wiper. It is the one that's going to move up and down. Imagine this arrow is moving up and down across this fixed resistance, which is 250 ohms. Now, here's a question for you. Now, I just said that this is a fixed resistance of 250 ohms. If I put my ohm meter here and here on the outside legs, and if I was to take this here pot, you know, you see one that's got a shaft on it, you're turning it back and forth, will the ohm meter resistance change as I turn this pot back and forth? What do you think?
Yes.
No, it will not, because this is a fixed resistance that I'm measuring. It will only change on your ohm meter if I'm on one of the outside legs and the wiper. The wiper is the one that changes the resistance that you're measuring.
Oh.
So for example, if I'm right dead in the middle of this here resistance with the wiper, like I have right now, and that means that you would think, well, from here to here, I'm going to have half the resistance, right? From here to here, I will have half of the resistance of this here total resistance of 250.
Mm-hmm.
So that means I would have 125 ohms from here to here. Well, that means then if I took my ohm meter and placed it here, and then I took this one and moved it up to here, then I will have 125 ohms from here to there.
Mm-hmm.
Okay? But remember, the wiper can be anywhere on that fixed resistance. Okay? So, let's say I go down here, and let's say I moved it up to there. Okay? Now let's say that I put my ohm meter leads right here and right here. Okay? And let's say that I check from here to here, and you see I've got more resistance here. That means that I'm going to have a higher number. So let's say I measure 200 ohms. Okay? Well, if I took my ohm meter and I went from here to here, measured between these two, what do you think my resistance would be? Remember, my 250 ohms is across the whole resistance.
It should be 50.
That is exactly right. I will measure 50 ohms. And now you understand exactly how
Wiper.
how the pot works. The wiper is the one that's called that where it's moving across this fixed resistance, right? And that will vary your resistance. So if we go back up to this one, looking at this one up here, right? It's the same exact thing. The wiper is moving up and down across this fixed resistance, okay? The only difference is when it's wired like this is used at this, they call this the potentiometer. But the same potentiometer can be wired like this, and then when it's wired like this, then they call it a rheostat. Because now they're looking at more, you're varying current versus this one where you're varying resistance. Keep in mind that you are actually varying resistance over here too. Okay? But can you see that if I put my ohm meter here, let's say I wire this thing up like this, right? And let me get rid of this. And let's do that circuit. Okay? And now, that is what I have. So, can you see that if I measure from here to here, do you think I'm measuring this resistance?
No.
No. You know why? Look, I am just measuring a jumper wire. So I'm going to get pretty darn close to 0 ohms when I measure between here and here. Right? Can you see it's a jumper? I am jumping out my resistance here. Okay? But if I was to go from here, right, to the wiper, which is between here and here, do you see I still have that little bit of the resistance that's still left? And let's say in my case that we're at an empty condition on the sending unit, then I would have my 40 ohms right up here. Okay? But at this end, right, that resistance has jumped out. So I have 0. Right? Now, can you see that the wiper, as it moves down, okay, as I move down here, can you see now that I am putting more resistance in the circuit? If I measure between here and here, And now if I get all the way down to the bottom, right, I've got every bit of my resistance in there. Now I have my 250 ohms of resistance from here to up here. So that's where I get my 40 to my 250 ohms is up here on the top side, where this side down here from the wiper over here is just grounded out. Okay? Make sense?
Yep.
Any other questions?
Nope. Let's get to work.
Alrighty. Okay guys, that will wrap up your school. So now you know how a fuel level sensing circuit works. So let's get out on the car, let's do a little diagnosis and let's see what we can come up with. So everything that I talked about here, we're going to use those same methods.